Hi, I'm Brian Sines, Project Manager.
Hi, I'm PJ Sapp. I'm hardware engineer.
Hi, I'm Matthew Seifert, software engineer.
And we are the Trio Technologies.
The Trio Technologies is a startup company based out of College Station, Texas. Our company's goal is to deliver durable and reliable products fit with the most innovative technologies today to create the products of the future.
We are currently designing a hand gesture control robot, also known as HGCR, for our customer Dr. Joseph Morgan.
In this project, hand gestures and movements will be detected by a glove worn by the user. The glove will be fit with pressure sensors, an accelerometer, and a gyroscope to sense the movements and gestures of the user, which are then processed by the sensor tag chip located on the back of the glove. The sensor tag then communicates the data collected from the sensors to a control board on the disaster robot via Bluetooth. The control board then processes the data and, based on the functions that are set to match the hand gestures and movements, sends signals to the control module on the disaster robot and performs the functions desired.
The HGCR allows the user to have full control of the disaster robot just by using simple movements and hand gestures. The easy control of the robot allows the user to send the robot anywhere he or she wants without leaving the user's workstation. This provides the user easy access to any location while the user continues the task he or she is working on.
Our design of our project will consist of implementing sensors into the glove that connect to the input sensor pins of sensor tag and designing the control board that will be placed on the disaster robot. The control board will consist of Bluetooth module that communicated to the sensor tag, a microprocessor to process the data received by the sensor tag, and the power regulation throughout the control board. The control board will be connected to the input pins of the motor control board, which will then send the data to the 12H bridge and then control the motors of the disaster
The
robot.
software for this project can be broken up into three distinct phases. First phase, data collection. The first phase consists of collecting signals from the sensors located on the glove and sending them to the sensor tag. A basic analysis of what kind of signals the sensor sent, as well as processing they receive in the sensor tag, will be needed. Phase 2 is the communication of data from the sensor tag to the control board located on the disaster robot. This would be done by sending Bluetooth signals to relay the data collected from the sensors and collected by an external module attached to the control board. The third phase and final phase is data translation and output. The final phase of our project is to translate the signals received from the sensor tag into a readable output to the motor control board, which is already installed in the disaster robot. The software on the disaster robot will make it so that certain pre-programmed inputs will issue commands to the motor control board. These three phases together should form a coherent system that allows the user to wirelessly issue commands to the robot in real time.
This is the conceptual block diagram for the HGCR. It details the design and function of our project. These are the sensors that will be mounted in various points across the glove. These will collect the raw data and concerning hand movements and gestures.
This is the sensor tag, located on the back of the glove. It processes the signals gathered from the sensors and relays said signals via Bluetooth to the control board located on the disaster robot.
The control board will receive the gathering data via a Bluetooth module located on the board itself. The signal will be fed into a microcontroller which will translate this signal into commands for the robot. This command can change the robot direction, speed, or pre-programmed routing for the robot to execute.
These are the disaster robot and the onboard motor control board. Note that we will not be building these, but they are crucial for our project. Thank you for taking the time to look into our project. We also want to thank our sponsor, Dr. Joseph Morgan, for this opportunity, and we are excited to continue growing as a company, leading the market with innovative technologies.